Okay, this is the 5th section in chapter 7, Trigonometry and Modelling from the Year 2 book. And this is about simplifying a cos x plus or minus b sin x. Now what this section is all about is basically taking an expression that looks like this and writing it like this in that form. Or it's taking an expression that looks like this and writing it in this form. Right. So the first thing to note is that actually the reason why we would change from this form over here to this form is that if I needed to solve an equation that had this in, it's easier to solve the equation if it's got that in its place. If I was trying to prove an identity that had this, or simplify something that had this in it, it's much easier when it's written like this. Notice over here you've got sine and cos mixed together. Here you've just got sine or cos. So basically these statements are equivalent. This will actually give you this, and it's interesting to maybe plot a graph of this form, and you'll see it's basically a graph of sine. So you could pick some numbers for a and b, use a graphing package like GeoGebra or something online, plot something like that, pick some values of a and b, and you'll see it's just a graph of sine. Maybe it's moved across a bit, or it's a bit higher or lower, but it's basically the same shape. The same with this. If you put sine and cos together like this, add them together to make a graph, you'll end up with a graph that looks just like cos. So these are equivalent statements, and it's about taking something that looks like this and writing it in a form that looks like this, and we'll go through the method in a moment. And actually there's probably only a few things you need to remember. We need to find out what r is. So r is the number that we put here. Now how do we find r? We find r by doing this. We take the values of a and b and we do Pythagoras on them. To find the value of alpha, I'm going to show you a slightly different method. It involves tan inverse. I'm going to try and make it as easy as possible. So I'm going to show you a slightly different, quicker method to work out what this alpha is. And basically it's going to involve doing the tan inverse of either a over b, or the tan inverse of b over a. So in these questions we only need to do two things. We'll be told which form it needs to go in, either the form at the top or the form at the bottom. We'll be told that in the question. What we need to do is just to work out what r and alpha are, and then once we've done that, it makes this expression over here much easier to deal with and much easier to solve equation, things like that. So it's probably best to get straight into an example. Okay, so this one here says show that you can express 3 sin x plus 4 cos x in that form. Okay, step number 1. Let's find r. R is just going to be the square root of those numbers a and b in front of sine and cos. So it's just 5. Alpha is going to be the tan inverse of either 3 over 4 or 4 over 3. Now how do we decide? This is where the addition formula for sine helps. Now if we look at this bit, imagine the addition formula and we expanded that. What would that look like? It would look like this: sine x cos alpha plus cos x sine alpha. Now compare that to what we have written just above it. Now I have a sine x here and a sine x here. I have a cos x here and a cos x here. Now let's have a look. Where the 3 is written, can you see the cos x is where the 3x was written, and where the 4 is written, can you see there's a, I said cos x, I meant cos alpha, there's a sine alpha there. So just by matching things up, I can say, well, where the 3 was, there's a cos alpha there, and where the 4 was, there's a sine alpha there. Right, this will help us. Tan is sine over cos, so we need to do the tan inverse of 4 over 3. So all I did was write out the expansion and match up the numbers with where the sine would be or where the cos would be. And you'll see that just makes things much, much quicker. Right, so if I do the tan inverse of 4 over 3, and I am in degrees, if I look at the range, so I need to change my calculator back to degrees and do tan inverse 4 over 3, 53.13 degrees, so alpha is 53.13 degrees. Now what does that mean? That means that 3 sine x plus 4 cos x is exactly the same as 5 sine x plus 53.13. Now I've rounded it. If you were to plot this graph and you were to plot this graph, they would look exactly the same. There would be no difference in them. We're writing an equivalent expression. It's an identity. So it's just written in a different way, and it's written in a way that's going to help us solve problems. Part B. Now, R is the same as before, but can you see this time it says cos and then x minus beta. Right, okay, let's see what's going on there. So that's 5 as before. Right, I'm going to do the same as what I did before. I'm going to write the expansion for this. That would be cos x cos beta. There's a minus sign there, so there should be a plus here. Sine x sine beta. Right, let's have a look. Let's try and match things up. Now, in blue at the top, let's try and color code this. I've got cos x and I've got cos x there. Probably not a good idea to highlight in the same color as the pen. So let's choose a different color and let's change and say, right, I've got cos x here and I've got a cos x at the top and I've got a sine x there and a sine x at the top. The reason why I did that is because I want to match things up. Now, where the cos beta is, what was there before? 4. So where the 4 was, there's a cos beta there. Okay, where the 3 was, there's a sine beta there. Okay, so how am I going to find beta? Well, I'm going to do the tan inverse of sine over cos 3 over 4. So can you see how it changes it slightly? So if I do tan inverse 3 over 4, and I get 36.87 if I round it to the 2 decimal places. So 36.87 degrees. So that one is done. It's not really done. We want to write down what the final answer is. So we can say that 3 sine x plus 4 cos x can also be written as 5 cos x minus, because that's the identity we've been given, x minus beta, and beta is 36.87. These are equivalents. Interesting to note, and maybe you can do this afterwards, what do these two angles add up to? And do they always add up to the same thing, something for you to investigate. Okay, so I'm going to do this the really quick way. The first thing I'm going to note is that basically it is like the number 1 there, 1 sin x minus root 3 cos x. This is the form we need to put it in. This tells me that I'm dealing now in radians, because you see pi there in the angle. Anytime you see pi, you know you're dealing with radians. So first of all, let's work out r very quickly. It's the square root of 1 squared plus root 3 squared, which is root 4, which is 2. R is 2, done. Right, then we work out alpha. Alpha is going to be equal to the tan inverse of either 1 over root 3 or root 3 over 1. Which is it? Right, so what we do is we work out what the expansion of this is. Sin x cos alpha minus cos x sin alpha. Right, let's compare it to what we were given in the question here. Right, so there's a sin x at the start. Okay, and next to the sin x is the number 1. What does that mean? That means that cos alpha is 1, because that's where 1 is, where cos alpha now is. Okay, let's now have a look at the second bit. It says root 3 cos x. So I have a cos x, and where the root 3 is, it says sin alpha. So we can write that sin alpha equals root 3, not negative root 3, because there's already a negative there. So if sine is root 3 and cos is 1, sine over cos, root 3 over 1, the tan inverse of root 3 over 1 is in radians pi over 3. So what does that mean? That means that sin x minus root 3 cos x is the same as, can be written as 2 sin x minus pi over 3. Now in part B, we're going to use this identity because we don't want to try and sketch this. Yeah, much easier to sketch this. So here's my method of sketching it. So there's no range given. So I'm just going to draw the graph of normal sine like that. Okay, I'm going to go back to there. So this would be like where 2 pi would be. That would be where pi would normally be. Yeah. And I know it would go up to 2 and down to negative 2. Now, because of this minus pi over 3, what I'm going to do, I'm going to rub out the axis there, and I'm going to move it to where negative pi over 3 is. Now, that's about, well, it is exactly negative 60 degrees. So I'm going to move the axis back to about here, negative 60 degrees. So I'm not going to move the graph, I'm going to move the axis. So this would be where negative pi over root 3 would roughly be. So I'm going to move the axis back to there. It still goes up to 2 and down to 2, like this. But obviously these values here are going to be different. I'm going to rub them out. It doesn't ask for what those values are, but it probably would be useful just to put some markers on there. There's our sketch. It goes up to 2, down to 2, and maybe at a later stage we can work out what these values are, where it crosses the axis. Maybe we'll do that now. Let's say I wanted to work out what that was, where it crossed the axis. Okay, now it crosses the axis when, well, there anyway, that first one, where it equals 0, where 2 sine x minus pi over 3 equals 0. Okay, so we can solve that and work out what x is. So that just becomes sine x minus pi over 3 equals 0. And then I think of it this way. When is the first time the graph of sine is 0? It's 0 when you do, so I'll just write it up here. The graph of sine is 0 when, or the first time it's 0, when the bit in the bracket equals 180 degrees, which is pi. When you've got pi in the bracket, when you do the sine of pi, you get 0. So the only way I'm going to get 0 here is if I make that equal to pi. And if I solve that, I'll get x equals 4 pi over 3 if I add it on. So I'll get my value of x. Okay, so the first time that, actually let's move this, the first time that sine crosses the axis as it's coming down is basically here. So that value is 4 pi over 3. And we could do something similar over here. Yeah, to do the same thing. What we could do actually is just take pi away from this to work out this one, and we can add pi to this to do this one. So I took the normal graph of sine and said, right, if this was a normal graph of sine, this would be pi. Okay, so that would be pi in there. So for that to be pi, x needs to be 4 pi over 3, so that's that one there. If I add pi onto this, I'll get that. If I take away pi from it, I'll get this. And if I make x equal to 0, I can actually get this value here, down here where it crosses the axis, by making x equal to 0. Right, okay, so on this one here, we're going to, part A, express that in the form r cos theta minus alpha. So r, nice and easy, square root of 2 squared plus 5 squared, which is root 29, I think. Now to find alpha, alpha is going to be the tan inverse of either 2 over 5 or 5 over 2. Now because I'm looking at the expansion of cos, the expansion of cos goes like this: cos theta cos alpha plus sine theta sine alpha. Okay, let's compare it with this. Right, what's here where cos alpha is the number 2? What's here where sine alpha is the number 5? So we do 5 over 2, tan inverse of 5 over 2. And we're back to degrees again. They keep you on these toes, keep you on your toes, these questions. So back to degrees, tan inverse 5 over 2, and we get 68.20 basically. 68.20 degrees. Right, so what have we got? 2 cos theta plus sine 5 sine theta is the same as root 29 cos theta minus 68.20 degrees. They're the same. That means if I want to solve this equation, 2 cos theta plus 5 sine theta, which is very tricky to do, I can actually change it to solving this equation, root 29 cos theta minus 68.20 equals 3. And that we can do quite easily. So cos theta minus 68.20 is going to be 3 over root 29. Right, so let's work out our principal value of, not theta, but theta minus 68.20, our principal value, by doing the cos inverse of 3 over root 29. So cos inverse 3 over root 29, and we get 56.15. 6.15. That's our principal solution. Straight to the cast diagram to find the other solutions before we start adding 68.20 to them. So we got 56.15 CAST. We landed in the part of the cast diagram where everything is positive. We're solving for cos. Where else is cos positive? Down here. So we want to work out what this angle is. Okay, we're solving between 0 and 360, so that angle is going to be 360 minus 56.15, and that equals 360 minus my answer 303.85. Okay, now that's what theta plus 68.20 is. I want to write it a little bit more clearly over here. Theta minus 68.20 can either equal 56.15 or 303.85. So if I want to work out theta, I'm going to have to add 56.15 to both of those. Sorry, 68.2. So 56.15 plus 68.2 gives me 124.35. 124.35. And if I add 68.2 to the 303.85 plus 68.2, I get 372.05. 372.05. This isn't in the range. So to make it in the range, find an equivalent angle by taking off 360. So if I take off 360, that's the same as 12.05. 05, so a little bit of working there. Lots of things that could catch you out if you're not careful. So our answers are theta is 12.05 or 124.35. Okay, there's another one here. So pretty much same type of thing. So let's start by working out r. Square root 12 squared plus 5 squared, 13. Let's work out alpha, which is going to be the tan inverse of something over something. I'm doing the expansion for cos. That goes cos theta cos alpha, sine theta sine alpha, and there's a plus in the middle. So there's the 12 is where the cos alpha would be, and the 5 is where the sine alpha would be in the expansion of this. So what does that mean? I do the tan inverse of 5 over 12, and am I in degrees or radians? It does not say, so let's go for degrees because my calculator's already in degrees. Tan inverse 5 over 12, and we get 22.62. 22.62 degrees. Right, part B. Find the maximum value of this function. Max is 13, easy, because the graph will go up to 13 and down to negative 13, because we've changed it into this 13 cos theta minus 22.62 degrees. Okay, and a maximum of that is 13. Whatever number is at the front here, that will give you the maximum and the minimum. That's the easy way of doing it. And then it wants to know the smallest possible value at which it occurs. Now the easiest way I find to do this is I want to think of the original graph of cos. So rather than thinking of translations, things like that, I want to think of the original graph of cos. Now the original graph of cos, when does its first maximum appear? Well, the original graph of cos, the first max is at 0 degrees, isn't it? Yeah, because it goes like that. That's where its first maximum is. And the next maximum is at 360. Now, what does that mean? Well, that means if I've got the graph of this, let's not miss the cos bit out, 13 cos theta minus 22.62. Right, when is this maximum gonna, well, when am I gonna get the first maximum? The same thing. When this is 0, the first max of this has to be when the contents of this bracket is 0, not theta, 0 degrees. Okay, what does that mean? So theta minus 22.62, doesn't matter what's in the brackets, the whole contents of that bracket needs to be 0 to get a maximum. Or the whole contents of that bracket needs to be 360 to get a maximum. So if I work that out, I basically get theta equals 22.62. So that's basically where the first maximum appears. If I wanted to know where the first minimum appeared, well, the minimum of the normal graph of cos would be here at 180 degrees, in which case we'll say, right, I want the bracket, the contents of the bracket, to be 180 degrees. So in other words, I would solve, let's write it down. So if it was asking about a minimum, let's do it in a different color. It's not asking about a minimum, but if it did, where does the graph of a normal cos graph have a minimum? 180. So I would solve this instead, and that will tell me where the minimum of this graph is. Same principle. Right, we are done. So once you've gone through that, now I think there should be plus minus here. Okay, there's some stuff there, I think, about doing some things independently. I will probably be going through those sections, so let me use a white highlighter pen if that's possible, which I can't do, to rub that out. So don't worry about this bit. Yeah, I will be doing videos on those chapters, so you don't need to panic. You can calmly do exercise 7e on pages 184 to 186.